Okay, it's time to get started. Thank you everyone for joining our live lecture today. My name is Isaac and I'll be the lead instructor for the lecture. And today's topic will be web security. So let's go ahead and dive right in and start by talking about your mindset as a web developer in regards to security. Okay, and first things first, you should always prepare for the worst and hope for the best. But that being said, before you start building any kind of software project, you should first determine what level of security is needed. For say just a static menu website for a local restaurant, there wouldn't be a high level of security needed because there's not any sensitive information involved. On the other hand, if you're building an e-commerce website that has passwords and payments and all that kind of stuff involved, then yeah, you would definitely need to heighten your level of security. So it's not one size fits all. You definitely have to approach each project, as it demands. Okay, next let's talk about your accountability as a developer when building software. Okay, so you need to be aware that you're bound by certain laws when building projects within certain scopes. And the two biggest scopes are handling of online payments and handling of online healthcare data. Okay, so whenever we're referencing handling online credit card info, we are going to reference PCI compliance, and we can find the official specs for that at PCISecurityStandards.org. And then you can look at the cybersecurity guidelines for HIPAA in regards to handling healthcare data. Okay, and of course, it's not every project where you'll be using those, but when you do, you do need to be aware that any breach of data can be you can be held accountable for. Okay, moving forward, let's talk about building security around actors. So as developers, it's hard to sit there and just think of all the security measures we need to put in place as we build. Instead, it's better to think in terms of actors. Okay, so an example of good actors would be users of the website that use it for its intended purposes, whereas bad actors would be users of the website that use it for their own motives. Okay, so when you think of these terms, it makes it a little easier to know, what role, permissions, all the good stuff to assign to, different people using your program. Next, let's talk about trust boundaries. Okay, so trust boundaries are divisions between areas of software that have different privileges. So we got things like client server roles, network machine boundaries, encrypted channels, authentication, and areas of responsibility within a system. So let's go ahead and go over each of those. We're going to start with talking about a computer network. Okay, so if you don't already know, a computer network is a collection of computers connected by a transmission medium. When you write software to the web, it'll end up being hosted on a web server, and then clients can connect to your server via web browsers, native iPhone and Android apps, and anything else capable of sending network requests. While this is great, it also opens a backdoor for trouble. Okay, so that's where channel encryption comes into play. And the reason channel encryption is necessary is because anyone on the same network can view all the traffic that you're sending and receiving. So in order to have private conversations between clients and servers, the channel must be encrypted. This can be accomplished using a TLS certificate and redirecting our web traffic from HTTP to HTTPS. Okay, so let's go ahead and take a look at a couple of examples of the TLS certificate providers. Symantec is one. Okay, they're pretty popular. And then Komodo is another popular one as well. Okay. And of course, there's others that you can use if you so choose. All right, next let's talk about API security, first in reference to endpoints. So because endpoints are generally publicly exposed, it's a good idea to set up some additional logic to verify the incoming API requests. So GitHub.com does a really good example of this. If you go to GitHub and you first go there and you don't have an account and you're a guest, right? They'll allow you to look at public resources, but you can't look at anything else. And then whenever you've logged in and created an account, then you can look at your own resources and, of course, public resources too. And then you can take it one step further, and if you have roles within the organization, then you can also request those resources. But as you can see, GitHub doesn't just let any network request go through to any resource, right? You have to be within a specific role to get certain specific resources. Next, let's talk about rate limits. Okay, so imposing a rate limit for requests made to your application API is a good way to ensure your site from getting attacked from several requests at once. Okay, so GitHub, again, has another good example of this set up on their API. So let's just go ahead and make a request to GitHub's API. And as we can see, they start us off with a rate limit of 60. But then after we make that request, we notice our rate limit goes down to 59. And this can prevent me from overloading their server with too many requests at once, which is actually a kind of attack, which we'll talk about here in a minute. Okay, so this is a good thing to set up in our own servers and our own APIs to protect against those kind of things. Okay. So next, let's talk about that kind of attack, the DOS attack. So denial of service attack typically is accomplished by flooding the targeted machine or resource with as many requests as once in an attempt to overload systems and prevent some or all requests from being filled. So we've got a couple of prevention methods for this. First one is throttling, and that's just limitation of bandwidth. Second one's rate limiting, which we just saw in action, limiting the amount of requests that can hit a specific endpoint. And then we've got web traffic monitoring, which is just specific tools we've got that we can connect to our software, and it can show us big spikes and unusual spikes in traffic, so we can take the necessary actions to mitigate damage by the attacker. So let's talk about some more vulnerabilities. So next time we're going to talk about is an XSS attack. And a cross-site scripting attack is a type of computer security vulnerability typically found in web applications. XSS enables attackers to inject client-side scripts, typically through an input of sorts, into web pages viewed by other users. Okay, and so what we can do to prevent against this, we can use something called sanitization. And sanitization, it normally comes in the form of a library, and it'll simply scrub your input for the data which is passed in. So if it's not a string or not a number, right, if it's something else as script, then it won't accept it, right, and it'll throw an error. So sanitization is the key to prevention there. Another kind of vulnerability we'll talk about is SQL injection. So SQL injection is a technique used to attack data-driven applications in which nefarious SQL statements are inserted into an entry field for execution. And then from there, they can, delete our contents, they can, send them back to the attacker, right? They can do a lot of other things. So to prevent against this, we can use sanitization and or an ORM. And ORM stands for Object Relational Mapping Tool. Moving on, another kind of vulnerability, file uploads. Okay, so one of the most commonly exploited web vulnerabilities is unrestricted file uploads. This can allow an attacker to upload an executable file, such as a PHP file, and then call the corresponding URL from the web browser. They are now running code on your server. So prevention methods against this, we can use file type detectors. And these are similar to sanitization libraries. They'll simply detect the kind of file, make sure, it's an image or some other file, and, it doesn't match any of the restricted uploads. And then it will proceed with the upload. Next, let's talk about ARP spoofing. So ARP spoofing is a technique by which the attacker sends spoofed address resolution protocol messages onto a local area network. Generally, the aim is to associate the attacker's MAC address with the IP address of another host, such as a default gateway, causing any traffic meant for that IP address to be sent to the attacker instead. Okay, this is very much like an interception, right? They're intercepting your request, and so preventions against this, we can use a TLS certificate. Okay, that's like we talked about at the beginning. Redirect our traffic from HTTP to HTTPS. Okay, another kind of spoofing is DNS spoofing. And it happens when we've got corrupt domain name data that's introduced into the DNS resolver's cache, causing the name server to return an incorrect IP address and resulting in the traffic being diverted to the attacker's computer or any other computer instead. And once again, to prevent against this, we have our handy dandy TLS certificate. So you'll notice that, that's a very standard thing to have in a secure web application. Okay, so if yours doesn't have it, you want to make sure that you don't have any sensitive data, because if you do, you definitely want to have a TLS certificate. All right, so now let's go ahead and talk about firewalls. So a firewall is a network security system that monitors and controls the incoming and outgoing network traffic based on predetermined security rules. It's always a good idea to make sure you have a machine, it's always a good idea to make sure the machine that your server is running on has one set up, okay? And this, varies. Some people run their server in the cloud, right, using a third-party service. Some people run it in-house. So, it kind of varies from project to project. But, you definitely should have one and make sure that you don't have just any traffic going in and out at all times. Next, let's talk about having a plan B. Okay, so no system is ever 100% secure. So it's a good idea to back up your data and operating system in case of emergency, so your service isn't interrupted for your end users, customers. As well, you should also have an emergency checklist in case you have service outage. You could, take immediate corrective action, and you're not sitting there scrambling, wondering what you need to do. You already have that all kind of listed out. Moving forward, now we're going to talk about organizational privileges. Okay, so as there's oftentimes a large number of hands involved with building a single software project, it's a good idea to restrict things to it's a good idea to restrict access to things on an as-needed basis. Okay, so for instance, a developer may have access to modify the code, but not to touch the production servers. And the operations team may have access to modify the servers, but not the code. Okay, so you see here, people only have access to what they need to have access to. Don't just give them the access to your entire project, right? Because people quit, people get fired, people have bad days, and the last thing you want them to do is, delete your database or something, unreversible, to where you lose your customers, or worse, you lose money because of it, right? So next, let's talk about protecting passwords. Okay, so I want to preface this with saying that there's several different ways to protect passwords, several different languages in which to do it. So there's no one way. The way we're going to teach you is called salting and hashing. Okay, so encrypting passwords, we first add what's called a salt, which is a long random sequence. And then once that's added to the password, we use a hash algorithm on it. And this is used to verify that the block of content hasn't changed. And so what it does for us on the other side is a couple things. After it's done, it makes it nearly impossible to guess the password without knowing the salt. And even if the attacker gains access to the salt, they won't be able to use the pre-computed hash to get the password out. They'll have to compute the entire space from scratch. As well as encrypting our password, it's also a good idea to enforce some sort of password strength rule. We've all kind of heard these before: a minimum of 6 characters, or must have a special character, something of that nature, just so you can prevent brute force attacks with easy guessing. Okay, so another form of authentication security is two-factor authentication. So I'm sure you've been asked once or twice to enter code that was sent to you on another device, such as your phone, onto the web browser you were using with a computer. And this is known as two-factor authentication, and increases the difficulty for an attacker because they'd have to compromise more than one device at a time in order to successfully impersonate a user. So if, for example, you left your laptop on the train or the subway, right, and someone steals it and they you know, they open it up and they try to get into your bank account, but the bank account sends a code to your phone, right? And asks them to, you know, enter that code. Well, now they're going to be stuck because they've only got your computer and they don't have your phone, right? So it's, you know, it's a pretty secure system when it comes to, you know, making devices harder to hack in that way. All right, let's wrap up with the topic of security resources. Where can you go to find, you know, the latest tips on protecting your projects from potential vulnerabilities? Okay, so we'll start with a government-maintained database known as CVE. Okay, as you can see, just come here, check out the vulnerabilities, latest reports, and prevention methods. Next, we got OWASP. OWASP, you know, as you can see, kind of looks like Wikipedia here. You know, just lets you search your security concepts and, you know, brings up, you know, little articles about, you know, that given topic. And then we got Verus, which is another database, but it's, you know, more community maintained versus you know, the government database we see here. All right, so let's go ahead and take a moment to open the floor, and let's see if anyone has any questions before we end the call today. So the floor is open. If you have questions, feel free to ask those now. Okay, I don't hear anyone, so I'm assuming we are all good. If that's the case, thank you everyone for stopping by. Have a great rest of your day, and happy coding out there.